Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are running on all the areas in science, and today we are here with you to continue on thermochemistry. We are going to take you through the types of thermochemical reaction, that is the exothermic reaction and the endothermic reaction. We are going to study the energy pathway for the reaction. We are going to study the energy diagram, that is the direction of energy from the reactant to the product and how they influence the reaction. And so this energy pathway is very important because we've already established that now in these two reactions, energy either comes in or goes out. And so we have to look at the direction of flow of energy from the reactant to the product. And so we are going to take our time to establish that. Now, let me first start with the exothermic reaction. Now, we said that in exothermic reaction, what basically happens is that the reaction progresses in such a way that large amount of heat is given off to the surrounding or is liberated to the surrounding. The surrounding tends to increase in temperature, and if you are close to such reactions, you have to go back because the reaction in such a way is happening that large amount of heat is given out to the surrounding. Now, when you look at this type of reaction, the direction of flow of energy begins from the reactant, and I'll give you example and so that you understand. Now, example, let's take this. Now let me take this. Now, assuming that you are burning a piece of paper, okay, so let me just draw the paper over here. So this is just a piece of paper I am burning. Now, basically what is happening that in the burning process, this process is called combustion. So let me just write it before. This process is called combustion. I'm going to get combustion. Burning taking place in oxygen or in air is called combustion. And so let's say that we are burning this paper. So let me just write the burning so that we all understand. So let's assume that we are combusting this paper. That is, we are burning this paper in air. Already we know that the surrounding is filled with a gas called oxygen gas that supports the burning process. And so let me quickly write the gases that will aid my burning. That is the oxygen gas. Without that in the atmosphere, there's no burning. So every burning that we see is accompanied or is aided by oxygen. So this is the oxygen gases, and this is the paper. So here is my paper. And let me indicate the burning by using the red around it. So this time we are burning the paper. Now you would realize that in the process, what started the reaction is this. This is what started the reaction. We are going to get the paper. That is what started the reaction. And don't forget that burning is a chemical reaction. Bonds are broken. That is, the bonds between the atoms are broken. And so paper plus the oxygen, definitely all what we see is a gas, that is carbon dioxide coming out. And then hydrogen inside the paper are all converted to some degree of moisture. That is, the water vapor also comes out in the process. And so basically, what do we have? We have the paper and the oxygen initiating the reaction. Now, in this reaction, you can see that as the burning is taking place, the heat is giving off. The heat is continuously giving off to the surrounding. And so you can ask yourself that where is the energy coming from? Where is the heat coming from? Now you can see clear that the heat is coming from the paper. The heat is coming from the burning paper and the oxygen. And so in this, the direction of flow of energy begins from the paper. So that is, the paper begins, okay, the paper is what gives off, the paper and then the oxygen, okay, is what gives off the energy. So the energy is given off to the surrounding. And so it basically means that the paper at the beginning of the reaction was at a higher energy level. The paper was at higher energy level. So higher energy level, the paper was having higher energy. So higher energy. So the burning paper, okay, that is the paper burning is what is giving off the heat to the surrounding. And so therefore you can see that the paper is the one that the burning paper is the one that is of higher energy. And at the end of the day, the paper goes, okay, it transforms itself to the ash that will also come out at the end of the day, the carbon dioxide and then the water. Remember that ash is also part of the process, but I'm not writing it, so ash also comes out during the process. And so basically you can see that the reaction starts with higher energy, and then at the end of the day it will give all the heat to the surrounding, and whatever comes out will end with a lower energy. So will end with a lower energy, okay, we finish with a lower energy. So basically, but the product, what ends up the reaction always ends with a lower energy. And so you can see that after the paper and after everything has happened, the gases and whatever comes out will be of lower energy as compared to this. Now, how is the energy flowing? You can see that the energy is flowing from the reactant. The energy is flowing from the reactant. The energy is flowing from the reactant in according to that direction. The energy is flowing from the reactant, that is the paper burning, and it is now ending to the product. It is flowing from the reactant to the outside, and then finishes with a lower heat content. That means that the product comes out at a lower heat as compared to that. And so basically, when you look at this diagram, everything is explained. That when you start with burning paper as a reactant, the paper, that is the paper which is the burning paper, will give off the energy. Now it means that the energy given off the paper is having excess energy during the burning process, and it doesn't know where to send it. So what happens is that the energy is given off. So you can see from this diagram that this is the vertical axis shows the energy, okay, for the reaction. It shows the energy level, and you can see that the reactant here is of higher energy that compared to the product. The height of the reactant here, according to this part, is of higher energy than that of the product. And so you can see clear that as the paper is burning and as the paper is combining with the oxygen and the burning is taking place, the two reactants are giving off energy. And so because they are giving off energy, they start with the higher energy. And then at the end of the day, they produce carbon dioxide and water. And the carbon dioxide and the water that is produced end with a lower heat content. So you can see from here that the energy level for the product is lower than that of the reactant. So this is a very simple process that can be understood. Most chemical reactions are like that. Burning, that example of a reaction that also is accompanied by this same diagram is I've already established that combustion reaction is a exothermic reaction. That means to give up energy, the reactant is having higher energy. Now again, most neutralization reaction is also an example of that. That is when you add acid to base, usually most reactions are also given off to the surrounding medium, and that is another one that you should also have to know. Okay, now we also have enthalpy of formation. Okay, we also have formation reaction. Let me just write formation reaction. Okay, all this we will take it one by one and we'll expose it, but let me just write formation reaction. For formation reaction, these are all examples of reaction that have this kind of things over here. That have this energy diagram. So let's look at this energy diagram carefully. There are things that we have to know. Now again, when you look at this energy diagram, the reactant is here, and then there is a term called forward activation energy. Now it is very important to understand that when you say activation energy is the minimum amount of energy that is supplied or given to a reactant in order to transform to become a product. Now every reaction, okay, needs some minimum starter. Have you gotten that? You have to start the reaction, just like the paper. Now without the lightening of the matches, the paper will not burn. So there is a minimum amount of energy that is supplied to the paper to keep on burning. And so that becomes the activation energy for the reaction. So activation energy is the minimum amount of energy that is supplied to the reactant, okay, in order to what, to react to form the what, the product. And so basically that is what we call the activation energy. And there are two types of activation energy. We have what we call the forward activation energy and the backward activation energy. Now in the forward activation energy, the reactant goes to the reactant. The energy supplied to the reactant to transform to become the product. And when you say the backward activation energy, in some reversible reactions, some product will also like to become the what, the reactant. In that case, the product must also absorb what, energy in order to transform itself to become the reactant. This one, for example, if the paper and if the carbon dioxide that came out from the burning of the paper and the water, okay, want to become the paper and then oxygen again, then they have to be what? You have to supply some amount of energy to those species, that's the product, before they can become this. That energy is what we call the backward activation energy. So that backward activation energy is also the minimum amount of energy that you have to supply to a product in order to become the reactant in this case. So that is it. Now, so this diagram is very simple to understand. Now again, one thing that's of importance in this diagram is that when we talk of energy, when we talk of thermochemistry, it is always the measurement of the change that is occurring between the reactant and the product. The change of energy that is occurring between the reactant and the product. And so we have to look at the heat change, that is the energy change that is taking place between the reactant and then the what, the product. And so when you look at this diagram, you can see that the enthalpy change or the heat change from the reaction, okay, is giving us, this is the mathematical, please, this is very important, is giving us the heat of the product from the sum of the heat of the reactant. This is the formula that is used to calculate all enthalpy changes. And so that is used to calculate all the energy change in the reaction or the heat change in the reaction. So this equation is the equation that is used to find the enthalpy change or the heat change in the reaction. And so you can see that if this is the equation, then it means that if you take the enthalpy of the reactant, which is of higher value, as compared to the product, which is of a lower value, because the negative is affecting the reactant, the end product becomes negative. Have you gotten that? Because the enthalpy value here is high compared to this. So if assuming that if here is say a 15 and here is 10, okay, when I take 15 away from 10, I will get what's called negative value. And so in exothermic process, the enthalpy change for the reaction is always what? Negative. The enthalpy change for the reaction is always in negative. Now this indicates that the reactant has given off energy to the surrounding, or the reaction is what? Is working, okay, on the surrounding. The reaction is already rather working on the surrounding. The surrounding is not working on the system. It's the reaction that is working. And so anytime you are working, you are dissipating amount of energy. And so that's why the negative value is there. So it's very simple. Now there's also another thing that we also have to know about the transition state. Okay. Now this is very important because most students do not understand. Now this is very simple. It means that when you supply an energy to a reactant, bonds must be breaking before the reactant, okay, but before the product is formed. Now basically what it means is that as the energy is supplied to the reactant is transforming gradually to become the product. It's just like you are burning the paper. Now when you supply some amount of energy to the paper will accumulate some amount of energy, and then if the heat is not enough, the glowing or whatever thing you are doing to the paper will stop. Okay, will stop. In that case, when we say transition state is a highly unstable state of what? Of a reactant that is of highly unstable state. Now this is because the reactant has gained some amount of energy in this case, and so it has gained energy. Bonds are just about to break in order to form the reactant. And so there is a particular point in every reaction where the reactant absorbs some amount of energy and become highly unstable. And that unstable state of the reactant is what we call the transition state. So this peak here you see here is the transition state. So once again, transition state is a highly unstable state of what? A reactant. that goes forward to form the reactant, that goes forward to form the product, or come back to form the what? The reactant. That is, if it is the transition state, if the energy of the transition state is not enough, then it will not overcome the barrier, but it will stay at where it is, or sometimes even return back. And so the point in a reaction where the reactant is highly unstable, that just a minimum amount of energy, or just a small amount of energy supply who can jump the activation barrier or return to form the reactant, is what we call the transition state. So transition state is very simple. So this is what we call the exothermic reaction. Now it is very important. This diagram is a very simple diagram for you to understand. In conclusion, I will take our next video on the endothermic diagram, and we also talk about it. But in conclusion, when we say exothermic reaction, once again, exothermic reaction is a reaction that liberates what? Energy to the surrounding and finish with what? A lower heat content. So when you look at this diagram, that the reactant has give off energy, and then the product is ending with a lower heat content. The difference between the difference between the reactant and the product gives a negative value. And this negative value means that the reaction is rather working on the what? On the surrounding, not the surrounding working on the system. So basically, and we define a transition state. A transition state is a highly unstable state of what? A reactant that progresses to either form the what? The reactant, that progresses to either form the product or come back to form the what? The reactant. And so basically, that is all about the endothermic reaction. These reactions, examples of these reactions are the combustion reaction, the neutralization reaction, and then the formation reaction. We will take each of these examples and we'll delve deep into it. Thank you.
My level up, my level up.
It's back.
Maybe today I don't get nothing, but tomorrow I go get something, and I go buy a motor for mama. But the enemy won't worry me. I go show all of them tragedy.